This is the solution video for question 36 from part B of the 2019 ECAA paper. In this question, we're asked to consider the expansion of ax plus b times cx plus d, where a, b, c and d are some real numbers. And for this, we're asked which of the following conditions is/are sufficient for the expansion of this to equal px squared plus q for all x, where p and q are some real numbers. We're given three possible conditions. Condition 1, b equals minus d. Condition 2, ad equals minus bc. And condition 3, a equals c equals 1 and b equals minus d. And we're given a list of possible combinations for answers for if conditions 1, 2, 3 are sufficient, listed from A to H, from A being none of them are sufficient to H being all of them are sufficient. So in this question, what we're going to do is we're going to look at condition 1, condition 2, condition 3 in turn, and see individually if they're sufficient and then put the table together. So how are we going to do that? Well, let's assume condition 1 is true, b equals minus d, and we're going to see what the expansion of this looks like. So if condition 1 is true, x plus b cx plus d is the same as ax plus b times cx minus b, because b is equal to minus d. So we have acx squared plus bcx minus bax minus b squared. And we see that this cannot be written like px squared plus q, because we don't know anything about a, b and c, so there's no way to know if this x term is 0. So we know that if we assume 1, we don't necessarily get our expansion looking like this. So we've got condition 1 is not sufficient. Let's do the same for condition 2. So we've got to take a slightly different approach here, because we could straight away sub in our information in 1. But in 2, it's not immediate, but it'll come out once we expand x plus b cx plus d, like this. So x plus b cx plus d, that's equal to acx squared plus bcx plus adx plus bd, just expanded normally. And now we can apply our information. So condition 2, ad is equal to minus bc. So that basically means this x term is 0. So we get acx squared plus bd. And that is exactly the form we want. So we've got, if we assume condition 2, our expansion looks like we want it to. So condition 2 is sufficient. So now, finally, condition 3. So a equals c equals 1, and b equals minus d. So we can throw all this straight away. We've got x plus b, and x, because a and c are 1, plus d, but d is minus b. So x plus bx minus b, which is x squared minus b squared, because it's difference of 2 squares, which is very clearly in the form px squared plus q, because we take q as equal to minus b squared. And so condition 3 is sufficient as well. So we know 1's not sufficient, 2's sufficient, 3's sufficient. We'll have a little look through our table and see that matches line D in our multiple choice. And so our answer is D.